Okay, so today's notes are on finding the greatest common factor. It's going to be 4.4C. So we're going to work on factoring an expression by finding the greatest common factor. Our language objective is to use the correct terminology when explaining that process. So we're going to jump right in. Our first example, I want us to factor the expression 6n squared plus 9n. So the first thing we're going to do, step 1, we're going to determine common factors of each term. So in this situation, we have 6n squared and 9n. So I know for 6 and 9 that they're both divisible by 3, and that's actually the greatest common factor for both of them. So I know I'm going to take out a 3 for each, and I'm writing it like this because I'm going to try to find a common factor that I'm pulling out of each of them. I also notice that they each have at least one n, so I know I can take the n out of each of them. So what I'm doing here, step 2, is I'm factoring out the common term or common terms. So I can take 3n out of each of them. When I factor that out of 6n squared, 6n squared divided by 3n leaves me with 2n. So that's going to be left there. And then 9n divided by 3n is going to be 3. So now I've pulled out the common factor. I'm going to pull it to the front using the distributive property. So step 3, I'm going to bring the common factor to the front, which is in more technically correct vocabulary is to use the distributive property. So when I do that, I end up with 3n parentheses 2n plus 3. So when I brought that to the front, reverse distributed is how I often say it, though it is just using the distributive property. I'm left with 3n times parentheses and 2n plus 3. Last thing, you don't necessarily have to do this, but if you're ever unsure, you can check your answer. You also should double check. I'm going to put a little note here. You should also double check to make sure there's no other common factors. I'm going to abbreviate common factors as CF. So when you get to more practice of this, you might find that after you pull out one common factor, you notice they have another one that you didn't previously see. So make sure, not only when you're checking your answer, but before that, make sure that you've pulled out every common factor. So to check our answer, we redistribute. So I do 3n times 2n plus 3n times 3, which is back where I just was, which leaves me with 6n squared plus 9n, which is correct. So let's do a quick check of that. I want you to factor 16x cubed minus 8x squared. So try that one on your own. I'm going to go over it in just a second. All right, I'm going to go over it now. So I know 16 and 8 are both divisible by 8, so I'm going to start pulling that out to the front. So I also notice they both have at least x squared, so I'm going to pull an x squared out as well. So when I do that, 16x cubed divided by 8x squared leaves me with 2x, and negative 8x squared divided by 8x leaves me with just 1. So now when I pull that 8x squared to the front, I'm left with 2x minus 1. And that should be my factored form. I can box both my answers in. And I noticed 2x and negative 1 do not have any other common factors, so that's all set, and I can redistribute just to make sure that I got the correct answer. So when I redistribute 8x squared times 2x gives me 16x cubed. 8x times negative 1, it gives me negative 8x squared, which is what I started with. It all checks out. All right, so that's that problem. We're going to do one more example together, and I'm going to flip the page to do that. I want us to factor 4x squared plus 20x minus 56. So now we're working not with a binomial, but a trinomial. So this time they're not all going to be, you're not going to be able to factor an x out of all of them, but there should be other common factors that we can pull out. So step one is again going to be to find common factors, or a common factor. So I noticed that they're all divisible by 2, but even more so, they're all divisible by 4. So what I'm actually going to do is pull a 4 out of each of them. So I'm going to pull 4x squared divided by 4 is x squared, plus 4, and then 20x divided by 4, it leaves me with 5x, and then negative, I have my 4 I pulled out, negative 56 divided by 4 leaves me with 14. I'm going to make a note here, just like I said in the last one, make sure you factor out greatest common factor. If you need to do this in 2 steps, you can do that, but make sure you always get the largest possible factor that you can pull out to the front of the equation. So then I'm going to do the same thing I did in the last problems. I bring the 4 to the front. I'm left with x squared plus 5x minus 14. And now this might look familiar. This looks like the quadratics we were factoring in our other lesson. So we're going to factor the inner trinomial like we would our other quadratics. So step 2, factor our inner trinomial. So I'm going to find factors of negative 14 that sum to 5. So I know my greater factor will be positive and the lesser one will be negative, since it adds to a positive but multiplies to a negative. So I have positive 1 and negative 14. I have positive 2 and negative 7. And sorry, I had those signs backwards. So this one's positive, this one's negative. So I have positive 14 and negative 1 and positive 7 and negative 2, and that sums to 5. So when I factor that, I'm left with x minus 2 times x plus 7. And this should be my factored form. So I pulled out my common factor and then factored my trinomial. As we always do, we're going to check our answers. So I'm going to redistribute my inner, or my binomials. So I'm left with x squared minus 2x plus 7x minus 14, which simplifies to 4 times x plus 5x, x squared, sorry, plus 5x minus 14. And I distribute and I get 4x squared plus 20x minus 56, which is exactly what I started with. So my factored form right in my box is correct. We're going to do 2 quick checks really fast. So I'm going to put them both here so you know to keep or leave room for both of them. So we have 9x squared plus 9x minus 18 as our first one. And our second one will be 4x squared plus 8x plus 12. So try those each on your own right now. Pause the video, give it a shot. I'm going to go over it. So you may immediately notice that each of these terms is divisible by 9. So I'm going to pull the 9 out front of each one. So I have 9x squared, 9x, and negative, 9 times 2. So I pull the 9 to the front. I can put parentheses around those as well. I pull the 9 to the front, and I'm left with 9 times x squared plus x minus 2. Now I'm going to factor this. So I'm finding factors of negative 2 that add to positive 1. So I have 2 and negative 1. That works. So then I have 9 times x minus 1 times x plus 2. And I'm going to box that in, but then I'm going to double check it. So when I redistribute, I'm left with x squared plus 2x minus x minus 2, which gives me 9x squared plus x minus 2. And last but not least, I distribute the 9x squared plus 9x minus 18. And that is what I originally had, so my factored form is correct. I'm going to draw a line here as we solve the second one. So here I have a common factor of 4, so I'm going to pull my 4 out front for each one. I'm left with x squared and then 2x and then 3. and then I pull the 4 to the front, and I'm left with x squared plus 2x plus 3. Here, I would try to find factors of 3 that sum to 2, but you might notice that's not possible. So the only factors of 3 are 1 and 3, and so they can't add to a number that's less than 3 without 1 being negative, but I can't have a negative and a positive that's multiplied to a positive. So this, it turns out, is not any more factorable than what we've already done. So I'll make a note, not possible to factor more. So our solution, or our factored form, is just going to be this. So that's all we have for today. Make sure you write down any questions, comments, concerns you have on any of these so we can go over them together in